Hello students, welcome back to today's class on whole numbers. In the previous classes we discussed what are whole numbers. In today's class we're going to learn some properties behind whole numbers, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. Before that, once again let's see what are whole numbers. Okay, so in the lower classes or whatever we are doing until now, we know how to count the numbers, right? We know how to count the numbers. We know how to count starting from 1. So 1, 2, 3 and so on. We will not start our count with 10 or 100. We always start our count with 1. For example, if you want to find the number of people in your class, you count 1, 2, 3, 4, 5, right? Okay, if you have a number of chocolates and you want to count how many number of chocolates you have, you say 1, 2, 3. But we never start with another number when we are counting. The starting number is always 1, right? So all those counting numbers are called natural numbers. All those counting numbers are called natural numbers. Okay, we have seen that. And how to represent them? We use the notation n, which is set of, okay, these two brackets represent set of 1, 2, 3, 4 and so on, right? In the same way we also discussed what are whole numbers, right? And for 1 we have successor. Successor means the next number, but we don't have predecessor. In natural numbers, for 1 we don't have a predecessor. Okay, you might have come to know that the number 1 has no predecessor in natural numbers. That means a number before 1. But there are still numbers before 1, and 1 out of the number is 0, right? So now we call all this a new set of numbers as a whole numbers. As whole numbers which will start with a 0. Okay, so it starts with 0, 0 and then 1, 2, 3 and so on. Whole numbers are represented with W. Natural numbers with N, whole numbers with W. The natural numbers along with the 0. Natural numbers along with the 0 form the collection of whole numbers. That is the only difference. How many number of elements is a difference between natural and the whole numbers is only one element, that is number 0. And what is the ending number of these numbers? No, these are counting numbers. We cannot end them. You say 100 as the last number, I'll say 1 lakh. Some other person comes with 100 crores. Some other person will come with 1000 crores and plus 1, plus 1, plus 1. So there is no end for natural or whole numbers. Okay, these two are continuously moving numbers. Growing numbers, you can say. Okay, so now let's try to understand how many whole numbers are there between 27 and 46. So between two numbers, how to find how many whole numbers are there, right? So from 27, let's try to write all the numbers. From 27, let's try to write all the numbers till 46. Okay, so what is that? 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45 and 46. Okay, 45 and the last number is 46. Now the question is, how many whole numbers are there in between them? We are not including 27 and 46, but how many numbers are there in between them? So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 numbers are there. Once again, let's try to count that. 1, 2, 3, 4, 5, 6, 7, 8 and 10. Yes, that's exactly 18. Okay, so how to get this number? It's okay. Between 27, 46, we just counted the numbers. If I ask you between 2724 and 4636, how many numbers are there in between them? So it is not that easy to write all the numbers and count. So what we do, we try to subtract the numbers. Okay, so tell me what is 46 minus 27? 46 minus 27, that becomes 16 and this becomes 3, right? So this is 9 and 19 numbers. But why we are getting 19 is we are including the last number 46 as well. Okay, 46 minus 27, we are including the last number also. So we need to subtract 1 from there and we need to get 18 numbers. Okay, the same concept will be applicable for any numbers. For example, I have very simple 3 and 5. How many numbers are there in between them? We know only one number, that is 4. But when you subtract, what happens? 5 minus 3 we go for 2, but it's not 2. 2 minus 1, 1 should come. Whatever the difference is there, just try to delete it. Just try to delete 1 from that. Okay, just try to delete 1 from that. I'll give you one more example. For example, if you go for 4 and 9. Okay, 5, 6, 7, 8. You know, 4 numbers are there, but 9 minus 4 is 5. So, but only 4 numbers are there, so 5 minus 1 is 4. Okay, so between any two numbers, the difference plus 1 will be equal to the number of elements between those two numbers. Correct? Between those two numbers, between number of whole numbers. When I say whole numbers, it is very important because in the coming classes you will be learning what are integers, what are rational number, irrational number, real number, complex number. So there are a lot of things we are going to learn. So whenever we are discussing about the numbers here, we by default we say that they are whole numbers unless and until it is mentioned that they are other numbers, right? So what's the next one? Find the following using number line. Okay, so let's try to use the number line to calculate all this. 6 plus 7 plus 7. Okay, so in the number line, let's try to plot all the numbers. Okay, so starting from let's say starting from 0, let's say whole numbers. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, we need all these numbers because there's a high count. So 6 plus 7 plus 7. So very easy. Starting from 6, so go for the next 7 numbers and then again for 7 numbers. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, so this is the first answer. 6 plus 7 is equal to 13. Now we need to go for 7 more numbers. 7 more numbers, right? 1, 2, 3, 4, 5, 6, 7. That will give you 20 as your final answer. Okay, so 6 plus 7 plus 7 is 20, and the same calculation method can be applied for any number of terms. I'll give you a sum of 10 numbers, 1 plus 11 plus 10 plus 100 plus 9 plus whatever it is. Just move on through towards the same number line. Okay, just add one by one. 18 minus 9. So here, if you take the same number line from 18, we need to come back by 9 units. From 18 minus states that we need to come back by 9 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9. From 18, 9. 18 minus 9 is 9, right? So from 18 coming back 9 units will be falling at 9. Next one, 5 into 3. So take a unit of 5 distance. So this is the 1, 5, right? And you need to multiply the same thing 3 times. You need to have the same 5 units length 3 times. Okay, so 0 to 5 is the first one, so 5 to 10 is the second one, and 10 to 15 is the second one. So you'll be landing up at 15. So 5, that is the 15. So that is how you can calculate using number line. All of these calculations are very simple. 18 minus 9 is 9, 5 into 3 is 15. You might have learned in the previous classes, but still using a number line concept, it will be very easy as well as very important. Correct? Next one we're going to see. In each pair, state which whole number on the number line is on the right of other number. Right, okay, for example, if you have a number line, so for number 3, which are the numbers right are the numbers which are greater than 3. So now, okay, so 895 and 239, which is greatest, which is least. Okay, so 895 is the greatest. So on the number line, 239 will be here and 895 will be here. So definitely 895 is towards the right of 239, right? 895 is the right of 239. All the cases, whichever is greater. Okay, this is the greater, right? So 10,001 is greater than 1,001. So 10,001 will be to the right of the number line. Okay, so if you take the number line, it is 1,001 and this is 1,001. So we have a lot of numbers in between them. So 10,001 is to the right side of 1,001. Okay. Next one, again the same thing. So this is the greatest number. So this will be the right to the number 28, 2,84,013. Right? It's a very simple. Just try to see which is greater, which is the least, and from there you can get the answers. The next question. Choose the appropriate symbol from greater than or less than. Okay, less than or greater than. We need to understand which is less, which is less. So this is less than, this is greater than. So 8 and 7, you know that 8 is always greater than 7. So we use the symbol. 5 and 2, again 5 is greater than 2. 0 and 1, 0 is less than 1. How can you bring all this using a number line? It will be very easy if you can draw number line 0, 1, 2, 3. My line is not that good. Right, so 0 and 1, 0 is to the left, 0 is to the left, so 0 is a small number compared to 1. 0 is a small number compared to 1, so 0 is less than 1. But whereas 5 and 2, so if we have 5 here, so 2 here, so So from 5, we need to come towards left. So 5 is greater number than 2. Right? In the same way, 10 is greater than 5. 10 is greater than 5. Clear? Next one. Okay, so the next important thing is the division by 0. Can we divide a number by 0? Let me tell you what is actually a division. For example, I want to divide 12 divided by 4. I want to find what is 12 divided by 4. How do you normally divide these numbers? Let's try to see that. 4 and 12. So 4 3 is 12, that becomes 0. Okay, let me go for 13. 13 divided by 4. So 4 3 is 12, and then we are left with 1 as a remainder. So now tell me, can we divide with 0? For example, same number 12 or 13, let me divide with 0. 12 divided by 0, so 0 and 12. So 0 1s, 0 0 2s, 0 0 3, 0. So we don't have any number which comes to the number of 1 and 2. Okay, you can start with 0 1s, 0, 0 10s, 0 20s, whatever number it is, still 0. Same 12 will remain as it is. The same number will remain as it is, but you will not get any answer here. Right? So that is the reason division with 0 is not possible, and we say that answer as not defined. We say that answer is not defined. Okay, so division by 0 is not defined. That's not a correct method to divide. We cannot divide 1 by 0. You cannot divide. It's undefined. You cannot tell the answer. You should not say the answer. And if you're taking the answer as 0, that's exactly wrong. Okay, that's correct. That's completely wrong. You need to define that as undefined. You need to write that answer as undefined. Clear? The next one. Commutative of whole numbers. Okay, in that we are going to discuss about addition. So now we are going to discuss about properties of whole numbers. So what do you mean by properties? Right, we add whole numbers, we subtract whole numbers, we multiply, we divide. So there will be some process or some properties that we need to learn before trying to solve the questions based on that. Okay, what is that first one? That is the commutativity, right, or commutative law. Commutative property. What is that? States that the commutative property of a whole number says that changing the order of addition does not affect the result. Changing the order of the addition does not affect the result. What do you mean by that? Okay, let's try to take an example. So 2 plus 3, you add 2 and then 2 3. Okay, you add 3 to the number 2, you will get the answer as 5. In the same way, let's try to interchange the numbers. So 3 plus 2. So what happens with 3 plus 2? For number 3, you need to add 2 more. So that will again give you 5. So A plus B or B plus A both are same. A plus B or B plus A both are same. So we can say that the commutativity is true for whole numbers. Or we can say that addition is commutative for whole numbers. Addition. We are talking only about addition. We should also talk about multiplication. We should also talk about subtraction and division. Subtraction, division we'll discuss later. But addition and multiplication are very important to learn. Okay, so addition is commutative for whole numbers. You can take any two numbers. Okay, for example, 5 plus 10, the other side you have 10 plus 5. You may be in a confused state, which is greater, which is not, which is correct, which is not. No, both are correct, both are equal, okay, we cannot say which is higher or greater, which is least. Both are same, 5 plus 10 or 10 plus 5. Right, next one. So the same kind of thing, commutative of whole numbers under multiplication. Just now what we have discussed, we discussed with addition. Let's try to take the same concept, the same examples with the multiplication. Okay, the commutative property of whole number says that changing the order of the multiplication does not affect the result. Let's try to take one example. So 2 into 3, we are not adding here 2 into 3, we are multiplying. So 2 into 3 is 6, as well as 3 into 2 is also 6. So if you interchange the numbers 2 and 3 and 3 and 2, the answer will not differ. The answer will be the same, correct? So we can say that even for division, even for multiplication, commutative property is valid. We can say multiplication is commutative for whole numbers. Multiplication is a commutative for whole numbers. Okay, so please try to copy that. It's very simple. Commutative of addition and subtraction both are same. Addition and multiplication both are valid with commutative property. The same way as commutative, we also have associative and other distributive and other laws. So that we are going to discuss all. Right. What is the next one? Associative of addition and multiplication. Associativity. So associative law or associative property. What is that? Again says that in previous, when we were discussing about commutative, we discussed only with two numbers, A and B, 2 and 3 or 3 and 2. But what will happen if the third number is entering into that brackets? If a third number is entering, we can say that observe the following: 3 plus 4 plus 5. So we need to add 3 plus 4 first of all, that is 7. For the number 7, we need to add 5. What is 3 plus 4? 7. 7 plus 5 is 12. 7 plus 5 is 12, right? What about this one? 4 plus 5 is 9. So 3 plus 9 is again 12. So if you carefully observe, both the answers are same irrespective of the way or the pattern you're following. You add in any order. You add 3 plus 5 and then 4. You add 4 plus 5 first and then 3. You add 4 and 3 and then 5. Whatever, however you jumble the terms there, right, you'll get the same answer. That is what associative property states that, okay? So we can say that addition is associative over whole numbers. Addition is associative over whole numbers, okay? A very beautiful concept. The next one, associative of multiplication. Let's try to see that. So 3 into 4 is 12. So 12 into 5 is 60. So 3 into 4 into 5 is 60. What about this one? 4 into 5 is 20. So 3 into 5 4 is 20. So 3 into 20 is 60. So carefully observe, both multiplications gave you the same result. We are multiplying the same numbers but in different order, different patterns, right? But still, whatever we are getting, the final answer is same. I can say like that, okay? So A into B into C is equal to A into B into C. You start in any order, that's not a matter. You start at any order, right? You pick up any number first, second, or third. You jumble the numbers, whatever you do. But if it is a straightforward multiplication, you'll get the same answer. Okay, so what is that? We can say multiplication is associative over whole numbers. Multiplication is associative over whole numbers. Okay, so addition, for example, we discussed about commutative. So in this, addition is correct as well as multiplication is correct. In the same way, for associative law or associative property, the same addition as well as multiplication are same. The same addition and multiplication, it is valid, right? So we discussed two laws, commutative and associative. Let's move ahead to see the next one. That is how to add this one. It's a very simple. 196 plus 57 plus 4. Just try to add in any of the pattern you want. Okay. So I'll just add these two because 196 plus 4. 196 plus 4. It will be easy to get the answer, which is 200. 200 plus 57 will give you 257. Will give you 257. You can arrange the numbers in a way you can. Right. The next one. 5 into 9 into 2 into 2 into 3 into 5, okay? So 5, maybe 5 into 9 is 45. 45 into 2. 45 into 2 is 90. 90 into 5 that is 15. 15 2 is 30. 5 that is 15. 15 2 is 30. That's what I'm saying. You can multiply in any manner you want, okay, in multiplication. So 9 into 3 is 27. So 2,700. 2,700. Okay, so 5 into 9 into 2 into 2 into 3 into 5. 5 is 45. 45 into 2 is 90. 3 to 6. 6 into 5 is 30. So 9 into 13. So 9 3s are 27. So 2700. 2700. Right. So moving ahead. Additive identity. What do you mean by identity? For example, you have your own identity card. What is that useful for? It is just representing you, right? It is representing you in the same way. Additive identity, we need to add some number, but we need to get the original answer as it is, original question as it is. What is that meaning? For example, for a number 2, I need to add some number to get the answer as 2 again. For the number 3, I need to add some number to get the answer 3 again. So what is that number? So that value is nothing but 0. So 2 plus 0, whatever number you add to 0, you'll get the same answer back. So 2 plus 0 is equal to 3 plus 0 is equal to 3. 2 plus 0 and 3 plus 0 both are equal to, I'm going to say 2 plus 0 is 2, 3 plus 0 is 3. Correct? So 0 is called the additive identity for whole numbers. Not only for whole numbers, for all the other number systems also. 0 is the additive identity. Right? Identity, please try to remember that you need to get the same answer back always. Right? The same way we have the next one, which is a multiplicative identity. Multiplicative identity, right? So again, identity means we should get the same number. In addition, we added 0 to get the same number, but in multiplication, you need to multiply with the number 1. 2 into 1 is 2 and 3 into 1 is 3. So what is the multiplicative identity? That is a number 1. Additive identity that we discussed previously, which is 0, this is a multiplicative identity which is equal to 1. Okay. So 1 is called the multiplicative identity. 1 is called the multiplicative identity for whole numbers. 1 is called the multiplicative identity for whole numbers, right? The next one we're going to see. Okay, so we have a question here. A milk vendor supplies 56 liters of milk in the morning and 44 liters of milk in the evening to a hostel. If the milk costs rupees 30 per liter, how much money he gets per day? Okay. Once again, let's try to understand what is the question. A milk vendor is there who is giving you milk. Okay. 56 of milk in the morning and 44 liters in the evening. So, what is the total milk quantity that he is giving? 56 plus 44, 6 plus 4, 10, 5 plus 4, 9, and then again 10. So, 100 liters. 100 liters of milk is being utilized. If the milk costs rupees 30 per liter, so cost is equal to 100 liters into 30. So, that becomes 3,000 rupees. 3,000 rupees. Okay, that is how you can calculate these values. How much money he gets per day? He will be getting 3,000 rupees per day at a cost of rupees 30 per liter. Okay, 100 liters, 30 into 100 is 3,000. Correct? Okay, so we have a couple of more questions as well as applications based on the whole numbers that we are going to discuss in the coming class. Right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Yeah. Hello everyone. So now we'll be discussing about the types of forces. So my name is Shashin Reddy. I'm a graduate from IIT Dhanbad. So let's go into the class. Okay. So here, first of all, we'll try to classify them into two types. Okay. We'll try to divide forces into two main types. And the basic difference between those two main types will be given here. So what difference do you notice between the forces? Here and here. Look at them. Look at both the cases. Look at this left case first. Here, which type of force is acting? Yeah. Here, the force acting would be magnetic force. And what is the main thing that you can notice? The main thing that you can notice is the balls are getting attracted even when they are not touching each other. Even when they are not touching each other. So, if force acts even when there is no contact. I can write force acts even when there is no contact. Even when there is no contact. Clear? Yes. But here you can see there is a person who is trying to lift a weightlifting. But here, to lift that weight, the person has to touch it. Contact is required. Contact is compulsory. Contact is compulsory. Yes or no? So there are two different cases we can see here when force will act. In this case, the weightlifting case, touch or contact is compulsory. The person has to touch it. Touch the object, touch the weight. But here the magnets, they get attracted even when they are not touching each other. That is, the force is acting even when there is no contact. So we have two different types of forces. What are they? One is called as contact force. The other is called as non-contact forces. Now very simple definitions for both. For contact force, those are the forces for which contact is required. Contact is compulsory. Example, muscular force. That weightlifting was an example of muscular force. Friction. There are many such examples. We'll go into them. But what is contact force? Forces for which contact is compulsory. Contact is required. What about non-contact forces? Those are the forces that act even when there is no contact, even when two objects are not touching each other. Example, magnetic force, gravitational force, electrostatic force. Magnetic force, we have a good idea. Gravitational force also, we have a basic understanding. What is electrostatic? We will learn about that. Okay, so let's go into each and every force, individual forces, one by one. Okay, so we'll start with contact forces. Contact forces, we have frictional force, we have muscular force, we have tension, we have spring force, we have normal reaction. Let's go into each and every one of them. Let's start with friction. So here, imagine this, or you can try doing it now itself, right now itself. You would have a table. On the table, just place a book and push the book slightly. You can say this is a book, this is a table. Okay, and push it slightly and see what happens. Okay, I'll just explain that to you. But something like this, look at the book. The book is pushed. What happens? The book will finally stop. See that? If you push the book moves and stops. The book moves and stops. So here, the motion was towards right. Now, why did the book stop? Who is stopping the book? Which force is stopping the book? In the effects of force, force decreases the speed, or force can stop a moving object. That is, if a body is stopping, a force should be acting on it, and which force is acting? That force we call it as friction. It is the opposite force. Motion is towards right. Friction will try to stop it by applying a force in the opposite direction. And who will exert friction? Who will apply friction? The table. Table applies friction. Okay. So what is friction? It is a force which opposes motion. Which opposes the motion. When you go into the chapter friction, then you learn about that in much more detail. We'll now go into the basics only. And in fact, all types of surfaces like solid, liquid and air offer the force of friction. Right, and friction acts in the opposite direction of motion. That you can really understand here. The second point, all types of surfaces like solid, liquid and air. It's a very basic, a very important point. Now, when does air offer friction? I'll give an example. Now, let's say you're cycling. You're cycling. Now, when you're cycling, let's say you're cycling bit fast. Can you feel that air will be pushing you back? You're cycling forward and the air will be pushing you back. We can notice that. All of you would have noticed it. Yes or no? So that air in that case is trying to oppose your motion. Is trying to decrease your speed. Yes or no? So what is, or which force is air applying? Air is applying friction. Air is applying friction. So that is one example of friction by air. Similarly, liquids, water can also apply friction. Understood? Okay. In simple terms, friction is the force which opposes motion. And how will it act? If motion is towards right, friction is towards left. If motion is towards left, friction will be towards right. So friction is in the opposite direction of motion. Basic. Clear? Okay. So that's friction. Now we have muscular force. Now we know what muscular force is. A force that is applied through the action of muscles. For everyday life, whatever we lift, right? For anything we have to lift, we have to apply force. And how do we do that? We apply that using muscles, muscular force. Right, so muscular force is a force applied using parts of the body like arms or legs. It is a force that results due to action of muscles. Yes. And most important point is that it is a contact force. Right, if I want to lift this pen, I have to touch it. Without touching it, I cannot lift it. There is no magic. Yes or no? So I have to touch it. So it is a contact force. And since contact is compulsory between us and the object. That's muscular force. Clear? And you can clearly see here, when you lift your hand, what happened? Your biceps, they are contracting. Right? You can clearly see the biceps. Okay? So they contract or expand depending on the case, depending on the action. But that's how muscles apply force. That's how we apply force. Clear? So muscles exert force by the action of contraction and expansion of muscles. A bit of biology, bit of bio. Right? Okay. Now we learned about muscular force. Now we learn about something called as tension. Not this tension, not the headache tension. Tension is force. Yes, it is. Force by what? It is force by a rope, by a thread, by a string. Okay? Tension is a force exerted by a string or a rope. Now imagine this. When you play tug of war, okay, you have a rope and you pull it. Yes or no? In a tug of war, there are two teams and the two teams pull the rope. Right? So the rope will apply force. So rope will apply force. That force is called as what? Tension. And where else can we see it? In a pulley. So in a well, from a well, if you have to draw water, we pull what? We pull using a rope. Some examples. Clear? So it is what? It is a self-adjusting force. Its value depends on case to case. Its value can increase or decrease. And most importantly, using a string, you can only pull an object. Imagine this. You are pulling water. You are drawing water from a well. You pull using a string. You don't push it. Push is not possible. You drop the bucket and pull the rope up. Yes or no? Yes. So using a string, you can only pull. That is the reason why. So a string can only pull an object such that the tension force is along the string and away from the object. So here, if this is the object, it is, let's say it is tied to a string. Okay. Now how will the string apply force? The string can only pull the box. You can only pull it, it cannot push. It can only pull. That's the specialty of tension, it can only pull. Clear? I'll just write that down here. Tension can only pull. Clear? Okay, that's wonderful. Now we have spring force also, which is force applied by the spring. Okay. Look at this. Now when you compress a spring, when you stretch a spring, does the spring apply force? Yes, it does. Yes or no? When you compress a spring or you stretch a spring, in both the cases. Yes? So the force applied by the spring is called nothing but spring force. Now how and all I'll explain. Look at this. A spring exerts a force towards the equilibrium or mean position when the spring is compressed or elongated. What does the equilibrium or mean position mean? Let me explain. Here, look at the different cases. We have different cases here. Look at the first case. In the first case is what we mean by equilibrium position, where the spring is not compressed, where the spring is not elongated. There is no compression, no elongation. So the spring is in its natural length. So here there is no force. So whenever there is no spring force, that is what? That is equilibrium position. Let's say this dotted line shows us what? This is the position of the block where we call equilibrium position. Spring is in natural length. It is not compressed. It is not elongated. So no spring force. But in the second case, the spring is compressed. Block has moved towards the fixed wall. The spring is compressed. Now when you compress the spring, how will the force be? Yeah, how will the force be? When you compress the spring will try to push away. Yes or no? So here the spring force See, it is towards the right. Towards right will mean towards the equilibrium position. This is the equilibrium position. So this arrow is towards equilibrium position. Right. Now when again if I take the third case, which is extension, when the spring is extended, when the spring is elongated, then see what happens. Then also the spring will try to pull it inside. So the spring force again is towards the equilibrium position. Understood? So that's what we mean when I say a spring exerts a force towards the equilibrium or the mean position when the spring is compressed or elongated. When the spring is compressed or elongated. Is that clear? Yes? Okay, wonderful. Now, that was spring force. Now we'll go into normal reaction. What is normal reaction? Look at these books. These books are placed on a table. Now, on these books, what are the forces acting? You can take one book, for example. Imagine that there is one book placed on a table. Everyone knows that's a gravitational force. Okay. So if gravitational force by Earth is acting, it should go down. It is not going down. That means there is someone stopping the books from going down. Who? The table. How? The table applies an upward force. And that force by the table is called as normal reaction or normal force. Okay. So here normal reaction is a force that acts perpendicular to surface. This is table surface and force is upwards. The normal reaction, the normal force is perpendicular to the surface of the table. That acts perpendicular to the surface. Simple. Is that clear? Understood? So those are some examples of what? Of contact forces. We started from friction, muscular force, tension, spring force, and normal reaction or normal force. Now, we'll go into non-contact forces or also called as field forces. These are the forces that act even when two objects are not touching each other. That is, when two objects are like this, they are like far away. They are like far away. Okay, so what are they? Simple example, gravitational, electrostatic, magnetic. Okay, I'll go into the explanation, don't worry. See, when we talk about gravitational force, let's say this is the ground. And let's say this is any object. So, and there is an object in air, and is that object touching the ground? No. But if I drop the object here, just let go of the object, what happens? That object falls towards the earth because of gravitational force. That object will fall towards the earth because of gravitational force. So gravitational force is acting on the object. Now again, are they touching each other? Is the object touching the ground? Ground is earth. So is the object touching the earth? No. No contact. But force is acting. So which force is that? Non-contact force. So gravitational force is a non-contact force. And look at this. There's an interesting video here. Okay. So there is that. Who is that? That's Newton. Newton sitting under a tree. And an apple falls on him. And he starts thinking that why is the apple only falling down? And that's how the story of gravity starts. Okay. But yeah, that's a simple story. We'll come back to the points. Objects fall towards the earth because the earth pulls the objects towards itself. Every object. Okay, earth will pull every object towards itself. That is, there is a force on us, on the screen, on the pen, on the remote, on everything that you can see towards the earth. Clear? And gravitational force, always attractive. Always. Earth always attracts things. Earth does not say no. Earth always says yes, yes, everyone come towards the earth. Clear? And it acts on all objects, even on air. In fact, gravitational force even acts on air. Interesting, right? Okay. Then we will go into magnetic force. What is magnetic force? For that, obviously look at these videos. Magnetic force is force between two magnets, or force exerted or applied by a magnet, in simple terms, right? So here look at this interesting video. Just a minute, I'll play it. Look at this. That will be interesting. What's happening? Magnet is getting repelled. That's the case of what? Magnets repelling each other. Right, that's the case of magnet repelling each other. But if I go with the other case, this case here, see what's happening. What's happening here? They attract. They are getting attracted, yes or no? So that is the example of attractive magnetic force. Magnetic or where magnetic force is attractive. So you know where it happens. Like poles repel each other, unlike poles attract each other. Simple. So magnetic force is obviously one thing that you could have noticed in the videos is the magnets attracted or repelled each other even when they are not touching each other, even when they were not touching each other, right? So magnetic force, as you can clearly see, it acts between two magnets or between a magnet and a magnetic material like iron. Yes or no? And contact is not necessary, yes, and can be attractive as well as repulsive. We just watched the video. It can be attractive as well as repulsive. Magnetic force. Very simple. Clear? Now we'll go into electrostatic force. Look at this video here. Have any time done this? Have any time played in this way? Just take a comb, rub it on your hair, place it on paper bits. The paper bits get stuck, right? They fly up and get stuck or get attracted to the comb. Yes, many of us would have played it. The question is, which type of force is acting? Is it gravitational? No. Is it magnetic? No, plastic is not a magnet. So there should be some other force. And how did that force start? By rubbing. By rubbing the comb on your hair, yes or no? Yes. The same thing, another similar case is here. It's a rod. A rod would have been rubbed with a cloth, and aluminum foil bits are flying towards the rod. Similar examples, right? So that is the case when we say when objects are rubbed against each other. Imagine the comb rubbing on the hair. What happens is we say that they get charged. What happens? They get charged. And the force acting between the charged objects, that we give it a special name called as electrostatic force. Electrostatic force. And contact is not necessary. The paper bits fly up without contact. It's not necessary for electrostatic force to act. Okay, simple points understood. There is one point which you have to remember as of now, so please remember. That is, it can be both attractive and repulsive like magnetic force. Just remember it as of now. Okay, so that's it everyone. We learned about what? Contact and non-contact forces and different type of forces or different examples for contact and non-contact forces. So please revise them and understand them properly and clearly. Okay, so thank you, thanks a lot.